all. So today we are going to do the third example question from the first chapter. The question is Coulomb's law for electrostatic force between two point charges and Newton's law for gravitational force between two stationary point masses. Both have inverse square dependence on the distance between the charges and masses respectively. So first of all, what is Coulomb's law for electrostatic force? The equation is Fe is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. Right. This is the equation for electrostatic force between two charges Q1 and Q2 separated by a distance R. And also for gravitational force between two bodies M1 and M2, the equation is G into M1 M2 divided by R square, where M1 and M2 are the masses of the two bodies and R is a separation between them. So they are telling that these two equations are having inverse square dependence on distance, right? In both equations you can see R square at the denominator. That is why it is told that they are having inverse square dependence on distance. In the first case it is between two charges and the second case it is between two masses. So first they are asking you to compare the strength of these forces by determining ratio of their magnitude. For an electron-proton pair and also for two protons. In the first part, in the A part, the first case is we have to find out the strength between these two forces. That means Fe and Fg. In the case of a proton and electron. Okay, a proton and an electron. So, what will be the electrostatic force when the charges are the proton and an electron? The equation is 1 by 4 pi epsilon 0 Q1 Q2. You know that both are having the same charge, only the sign is different. So I am representing the charge of proton and electron both by the letter E, since both are having the same value 1.6 into 10 raised to minus 19. So I am writing it as E for a proton, but when it comes for an electron, a sign will also be there, minus E divided by R square. Okay, so you can write it as minus 1 by 4 pi epsilon 0 E square by R square. Okay, now about the gravitational force Fg. What's the equation? G into M1 proton and M2, that will be electron, divided by R square. Okay, now they're asking you to take the ratio between these two. What they're asking to compare these two forces. For that we have to take the ratio of their magnitude. Okay, so I'm doing Fe divided by Fg. Okay, what is Fe? I'm substituting the value. We are taking only the magnitude of that, so no need to take the sign. Okay, so it will become 1 by 4 pi epsilon 0 E square by R square divided by G MP Me divided by R square. Okay, so from this R square and R square are coming common in top and bottom, so I am cancelling it down. So the balance is E square by 4 pi epsilon 0 G into MP into Me. Okay, that is for what? That's the ratio of force between what? A proton and a electron. The ratio of forces for a proton and electron, ratio of electrostatic and gravitational force in the case of proton and electron. We have to substitute the value and find out the answer for this. Okay, I will give the values for substitution, but first one is E. You know the value of E is 1.6 into 10 raised to minus 19 Coulomb. Another one is what? 4 pi, then epsilon 0. The value of 1 by 4 pi epsilon 0, the value is what? 9 into 10 raised to 9. Okay, Coulomb square, no, Newton meter square per Coulomb square. Then G is there, right? For G, what is the value? 6.67 into 10 raised to minus 11 Newton meter square kilogram raised to minus 2. That's the value of G. Then another thing is what? MP and Me, right? For mass of proton is 1. It's given in the question. 1.67 into 10 raised to minus 27 kilogram. Me is the mass of the electron. It is 9.11 into 10 raised to minus 31 kilogram. So you have to substitute all these values, okay, in this equation to find out the answer, and once you have done the calculation, you will get the answer as 2 point, the answer will be 2.4 into 10 raised to 39. Okay, since it is ratio, it has no unit, but the answer is 2.4 into 10 raised to 39. Okay, in the same way, this is the answer for the first part, A part, first one. In the same way, they are asking for what? The force between for two protons, in between two protons. Okay, two protons. So, when it comes in the case of two proton, Fe by Fg, the formula will be Fe by Fe by Fg will be again Fe will be the same thing, 1 by 4 pi epsilon 0. Since both are protons, E square by R square. Okay, and when it comes to gravitational force, G into mp into mp, both are protons, so mp into mp, so we can write it as mp square divided by r square. R square and r square can be cancelled, so it will become E square by 4 pi epsilon 0 G mp square. And its value, when you substitute all the values, you will get 1.3 into 10 raised to 36. Okay, so we finished the A part. Okay, I think it's clear for you now, the A part. Now we have to do the second part, B part. So these are the two answers that we got for the first and second part of A. Okay, and when you check these two answers, you can see that this is the ratio of Fe by Fg, and we got a bigger answer for this, which means that electrostatic force is very far greater than the gravitational force. Because the answer we got is a bigger number, which suggests that the electrostatic force is enormously stronger than the gravitational force. Now we are moving to the second part, B part of the question. In B part they are asking, estimate the acceleration of electron and proton due to the electrical force of their mutual attraction when they are 1 angstrom. 1 angstrom means 10 raised to minus 10 meter apart. Okay, so they are asking you to find out acceleration from Newton's law of motion. You know, F is equal to ma, where F is a force, m is the mass of the body, and a is the acceleration. So from here you can write a is equal to F by m. Okay, now in the question they are asking you to find out the acceleration of the electron and also of the proton. Okay, so first we can find out the acceleration of the electron. I am putting it as AE, that is equal to what? Force divided by mass, right? First we have to find out the force of attraction. Force of attraction between an electron and a proton, right? So equation of force is F is equal to 1 by 4 pi epsilon 0 Q1 Q2 both are E, so E square by R square. Okay, so 1 by 4 pi epsilon 0 is 9 into 10 raised to 9. E square is 1.6 into 10 raised to minus 19, the whole square, divided by R square. They told the distance is 1 angstrom, right? So 10 raised to minus 10 square. Okay, so you will get, on solving it, you will get the answer as 2.3 into 10 raised to minus 8 Newton. Okay, so this is the force of attraction existing there, the electrostatic force of attraction existing there in that particular case. Now for finding the acceleration of the electron, AE is equal to F by m. F is what? 2 point, here mass of electron, so I am putting it as me. So 2.3 into 10 raised to minus 8 Newton divided by mass of the electron. Mass of the electron is 9.11 into 10 raised to minus 31 kilogram. Okay, on solving it, you will get the acceleration of electron as 2.5 into 10 raised to 22 meter per second square. So this is the acceleration of the electron. Now again you can find out the acceleration of the proton. For getting the acceleration of the proton, the force is same, F divided by mp. F is what? 2.3 into 10 raised to minus 8 Newton divided by mass of proton is 1.67 into 10 raised to minus 27 kilogram. And on substituting the answer, you will get 1.4 into 10 raised to 19 meter per second square. So you can see that the acceleration of electron is more than that of the acceleration of proton. Okay, and these accelerations are very far greater than the acceleration due to gravity. Okay, so this question had two parts. In the first part, we compared the strength of the electrostatic force and gravitational force in two different cases, for an electron and a proton pair, and also for two protons. And we got these two answers. And in the second part, they are asking you to find out the acceleration of electron and proton due to their electrostatic force. So for that, we use a Newton's formula to get the equation for acceleration as force by mass. Then we found out the value of force by substituting in this equation, and the distance between them is given as 1 angstrom, that is 10 raised to minus 10. So substituted that value and found out the acceleration for electron. Again for proton, same formula, but mass is the mass of the proton, and you will get this final answer. Okay, thank you.